Okay. So I don't know, do you guys want me to do that again? So Control P, then let's say new file, then test.c. And just kind of getting used to the flow of doing that. Okay. Now a little bit into C. So, who made C? Dennis Ritchie, right? This guy, guy on the right, created it in the 1970s, and it kind of just gained more traction from there, right? It's statically typed in comparison to if you've gone to one of the JavaScript sessions, that is dynamically typed, and I'll talk a little bit more about that. Procedural, and that it's very, very close to how machine code and how binary actually runs on a computer. Afterwards, I'll share with you guys a YouTube video you can look at where they actually compare some C code to assembly and to actual binary itself.
Wow. So this guy made C. No
Him
wonder
plus
he was
other
so
people,
tired.
but he's the main person.
The poor guy. He was so tired.
So, I mean, it's a very old standard. If you compare C to any other language, so if you look at C++, C++ has changed a lot in the past 5 years. C has mainly stayed the same. There's been minor changes, some for undefined behavior, right? Things that everybody doesn't like. Undefined behavior, it's random, right? Other than that, C has just, because of its place as a root language, right? A lot of other languages, they spring root from C, right? They add other stuff on, but they start from, they like to call it the mother of all languages in a sense, which is why the university teaches it all. Okay, it's the most building basic block. The reason why we want to use this for this project is we want it to be as fast as we want, because of we're using a Raspberry Pi. We have a limited amount of processing power, right? We want to squeeze as much processing power out of that, right? And then if we move further on to kind of microcontrollers, we even have less power to work with. So low-level code is very important in that sense, right? That's why we want to do all the management ourselves, compared to other languages where they give you garbage collectors, they give you all this extra simplicity, right? For other languages, you can just do like a sort, and it'll automatically sort for you no matter what kind of a list you give it. But that gives you a lot of overhead. And then another interesting aside about C++, C++ used to be a lot more inefficient than it is now, right? So as it's iterated through, C++ has become a lot. There used to be a big gap of performance between C and C++. Now there is a gap, but it's less so compared to when C++ first came out. So that you also have to think about that when you're reading online documentation. You might find some really old, outdated documentation and see that, oh, this is very inefficient. This is like 3 times as fast, right? 3 times as fast to use C compared to C++, right? But you have to also take into account that you have to know what you're doing in C++ to kind of get that close efficiency. If that makes sense. Any questions?
I know that C++ is a superset of C, or that it's backwards compatible with C.
Mm-hmm.
So I don't know if C++ will have less control over the hardware compared to C. What do you think?
Well, I can add a bit here. Also, that used to be the case, but now they're like really different. They are sometimes backwards compatible, but sometimes they add C++ code will be able to run C code, and C can't. It's a way.
There is some funkiness in compilers, right? So differences between compilers can, for example, cause C++ code not to run, or C++ code to not run C code. So the general rule is yes, very compatible, but say again.
It's a gamble.
It's not as big of a gamble. It really depends on what you're doing. Really, if you're really digging deep, you might come into that issue. I don't see us going that deep into C, C++ ish stuff. So for the compiler MGW, right? MingGW, right? They're the same compiler for C++ and C. It compiles C++ and C. Same as if you have GCC on Linux, you can also compile C++ code, right? So they're the same compiler. There's also differences. There are also some kind of hidden proprietary compilers that can kind of affect efficiency. Those are kind of used in industry. Only businesses really use those because they actually want to juice out that speed, right? So if you have a little smarter of a compiler, you might be able to edge out a couple milliseconds. And for some applications, a millisecond is massive. Like now, the expectation is you open your internet browser and it should run within a second. If it takes more than a second, you're like waiting, wondering why is it taking so long, right? So time is very important, and especially in the cloud, time is literally money. When you're running virtual machines in the cloud, you're paying by the hour, right? So if you can push more commands per hour, you're saving money. Does that answer your question?
Yeah.
Okay. All right. Putting C together, right? So in contrast to JavaScript, we are C is statically typed. What does that mean? Everything is decided at compiler, right? At this step, you have a preprocessor, compiler, assembler, and linker. At this step, the data types for everything is decided, right? The size of whatever variables that you declare and what their purpose is decided at that point. Where in comparison, JavaScript doesn't really have the similar compiler, but at runtime, when it's running on the system, it's deciding on the fly. This is also where you kind of get into, if you go into, I think 1106, 2312, they talk about standards again for compilers, right? Differences between variables compiled on one compiler can be different because of the variable that you're saying, right? In some systems, an integer is long as a specific size. In others, it's a smaller size. It's kind of a variable length. That's why they go very in depth in those courses where they'll make you use, I think it's int, and then you specify the size of the integer afterwards, how many bytes it is. That's how much detail you're going into. I don't see us having that issue. Another thing about C is that when you compile, right, you compile for that system. So if I compile something on Windows, right, using MingGW, and I get a .exe, I can't just take that and run that on Linux. It could work, but generally you do not want to do that. Their binaries are specific to the OS. Okay, and then we're talking about data types. So this is a really good representation of stuff. Obviously includes stuff from C++, which we won't cover. So classes, some union, and I think some other stuff. But generally everything, wide characters I think is only C++. And Boolean is kind of sometimes in C or not, depending on how you import the libraries, right, for the preprocessor directives, right? So you have integers, characters. A string of characters becomes a string, right? When you're making strings, you also need to consider that you need a null terminating bit. You need an extra, if you have 10 characters of information, you need a null bit because you need to know when to stop, right? You're running everything. So you need to know when to stop when you're doing that kind of operations. Double floating point, floating points. This is kind of enters into the realm of questionable issues that might arise. So precision is a very important thing, right? The problem is the way we represent numbers in computers is not the way you would think they are, right? if you've ever seen those kind of internet videos where they're like, okay, you write a number, right? It's like 0.400, right? 1, right? But then it will show you 0.500 or something along those lines, right? That is the limitation of the definition of precision for these data types, right? More precision than that doesn't fit inside the data type. That's why you get that. If you talk about more into that category, so C is used a lot in kind of like science, supercomputer work, right? So when they're trying to do large computations that require massive numbers, like way too many numbers to count, I'd be writing on the board a lot, right? They actually use a completely different storage system for those values, just to get around some of the issues that arise from these, the precision and the floating points. Then you have void. Basically, there's nothing there. Functions, arrays, pointers, references. You can kind of think of these as kind of addresses to things, right? If you watch the video that I'll link to afterwards, it kind of shows how a function is really just an address. And it goes to somewhere in the code. It'll go to the code, and then it will run through whatever that function is. And then it'll jump back to wherever you are. Something to think about. Arrays are also addresses. Pointers are literally a data type just to store an address to something, right? So I think we'll cover it a little more later, but just remember everything has an address, and that address sometimes, because of how we pass stuff through functions, we need to know that address, right? And that's where memory management comes in. Then you also have structures, enums, union-ish stuff. We won't really cover those. We'll probably cover some structure stuff in this project. A little more about the size of these. I think I'll cover this. Naming things in C, okay? So there's 4 rules you need to follow. Variable names can only have letters, digits, and underscore. And then if you're talking about the first letter, right, it has to either be a letter or an underscore. Can't start with a number. And and then there is this kind of ish rule, again, compiler issues. They don't like something over 31 characters. So if you can keep that below 31 characters, then you'll be just fine. It's kind of back into the 2312 stuff, storing, you have to store that variable size, if that makes sense. When you go further on, you can just think of a computer has a list of commands, and those commands have a certain amount of size, right? So to deal with stuff that goes over that certain amount of size, you kind of have to build in overlapping, right? So in 2312, we'll talk about what a word is. A word is 16 bits. Sorry, 16 bits or 16 bytes. But that is like a command, and that is a specified size, and there's no changing that size. That's an ARM architecture. There's different architectures. That's why it's also included this. It should be fine over 31, but sometimes you might run into an issue. And then obviously reserved words. Reserved words are special words used for a specific purpose. So char, constant, break, for, else. Things that you will be using in your code, you should not be mirroring that. Okay. Another important thing to think about is scope. So variables, they only exist within your wherever they are defined, unless specified otherwise, right? So something up here, avoid. Just imagine this is like one big function, right? This isn't a global variable. Side note: do not use global variables. You will most likely get a 0 if you submit it to any of your coding professors with a global variable. It might not be stated explicitly, but a lot of professors will explicitly state it in their syllabus, and they'll expect you to read their syllabus. So that is something you should never do. There's a methodology behind it, and generally that is the case. The only kind of cases where you can kind of get away with it is when you need to pass specific variables related to something. For example, if I need to know what the ASCII value for arrow up for a game, say I'm doing something C and I'm making a game, I need to know the value associated with the keyboard press of up or down. Does that make sense? And I've crossed out the parts where it's C++. We're not going to deal with that. Okay, and then here is getting started, right? Every programming language, the most basic step is just hello world, right? So hello world consists of 4 parts here. So the preprocessor directives are just telling the compiler, hey, I need to be able to access this. Kind of included in the linker. Then you have your main, which is the master function where everything runs. Then you have a printf, and then a semicolon. Every single command needs to end with a semicolon. So if you did, we can do simple main.c include. So I'm including stdio. So it's standard in, standard out kind of library. That'll let me print f and use that. Main, then I can see the colorization of the brackets. And then printf. And then let's say hello world, right? And if you save that and you go to your terminal, and let's say you run gcc main.c. Oops.
Now you have to use Ubuntu or Windows.
I'll just,
Do you have Ubuntu installed on your
no,
terminal?
I'm using MinGW, so it should just work. I just have to cd into the right directory. Okay. That's also going back to, I think I explained that in the last session, but anytime you update an environmental variable, so we kind of do the edit environmental variable and you add something new, right? The terminal needs to update to tell itself that, hey, I've included this other directory that, hey, if you're searching for something, you can look there. But since I had started VS Code before that, it doesn't know it exists, essentially. And then you can see ls, right? I get an a.exe. Zoom in a little bit. Right? And then to run it is the same as on Linux, right? So if you know Linux, you will run a.out. But in this case, e.exe, right? And then I have hello world. Okay, and then commenting. It's coming back to kind of making sure that your code is easily readable. So let's say I want it. So this is a perfect opportunity to include a shortcut, right? Control / will turn any line that you're at into a comment. So if I press enter, also whole demo moving stuff around, alt up and down, very easily slide up and down. And then if I press control / again, it'll uncomment it. So say I want to say something up here. This program prints right, and then I'll press control / and then I'll make that a comment. And I think control no, it doesn't matter. Okay, and then here is a list of operators. So if you can see the you can see the unary, the kind of divided into three kind of sections. Unary operators, which are kind of single line commands. Binary operators, which are dealing with relationships in a more plus and minus are very simple code to run in assembly language, right? So that's why they're put in their own self by themselves. And then ternary operators. It says question mark dot. A lot of professors won't really cover it, and I think it's rather interesting. If you go into digital logic, you'll cover it a lot. Okay. So essentially it's saying statement, right? If this is true, value 1, and then if it's false, value 2. I myself rarely use this, so I might be using it wrong. Right? And then you have your relational operations. So mathematical operations. Also, one thing to remember is that divide is not the same as normal division, right? And this modulo operation is not the same. Relational operations, kind of comparison. Logical operations, kind of take two statements and then do logical checks with them. So and, or, not between them. And then bitwise operations, more granular commands. So if you take a string of bits and you AND those together. So if you have one ANDing is if you say you have AND means both of them have to be true for you to have a true result. Or is one or the other has to have a true result, and it'll be true, right? These kind of low-level changes in numbers, 0, 1s. That's why they're called bitwise, right? You're dealing in bits. And then assignment operators. This is the most basic. The most basic is equal to, right? Plus minus is just taking an operator, the arithmetic operations, right? And then adding that, kind of building that onto whatever original value is. So A plus equals B, right? And these are both numbers. It's just going to add B to A, and then it'll store that value, whatever value it is in A, essentially. You're just kind of adding this to this. Instead of in comparison writing equal to A plus B. Also, in another aside, don't ever do multiple pluses like this, right? You could think you could do this, but because of how the C standard is written, you should only do one of these at a time, right? If you do more than one and you're running more stuff in that line, you can result in issues. The reason why is because the compiler will say, this goes back to the assembly code, right? It'll add it once, right? And then that other add might be pushed down into another command. So if you run everything in that first command, you'll run it with 1++, not with the 2++, right? Just something to think about. Does that explain that? Any questions? Okay. And then here are the basic conditional statements. Right, you have if else, else if, and a bunch of else ifs, and switch, right? For if is the most basic kind of conditional check. If else is, you can kind of think of these diamonds as decisions and the rectangles as code. So if true, then run the code. If false, then the line will go to the end, right? And this is the same way. So if false, it'll just run whatever is in else. This is also how this operates. So if this is true, then I'll run the first if and then end it. But if that's false, then I'll go to the next one and the next one. And then if that is also false, then I'll do the else block. But if this else block isn't here, it'll just go straight through. Then you have switch statements. Switch statements are very niche in their usage because you have to give them a number. They're expecting a number. Not everything you want to one thing to think about is say you're kind of making a quest-based story game, right? You would think that you could easily use the character input the player gives you to decide which case statement to go to, but that needs to be in a number value. That also goes a little bit more into the compiler backend. Why it does that is because it kind of needs to easily be able to search through numbers, right? As compared to characters. This is another code example, right? If statements and then the codes inside. Just kind of showing you again. When dealing with switches, one thing very important to remember is to always have a break after each case. If you don't have a break there, it'll just go on to the next one. It is sort of switches really, now that I didn't understand why I did that before, but now because I've done assembly language 2312, right? This makes a lot of sense. In assembly, I wish I had a marker, but you would write a go-to statement to a command, to a part in the code, right? And if there's no other go-to statement, it'll just keep going, right? Or a conditional send to somewhere else statement, right? If that's not included, it'll just keep. Oh. Okay. So a little bit into this assembly, right? So let's say you have some function is called add, right? This is kind of the ARM notation for this function. And then you have kind of like add commands. And then I'll introduce you guys to what registers are. Registers are, have you taken 2312? Yeah. Okay. So registers for ARMv7 would be like R1, R2, and these are just, these are 4 bytes in size. 4 bytes? 4 bytes. I think it's 4 bytes or 8 bytes. 8? 4, 8. I can never remember. But let's say you have this command and you're adding R1, and then you'd be like add R1 and R2. This is essentially the equivalent of saying R1 equals to R1 plus R2, right? So now you've given this command. If there is no go-to statement somewhere after here, right, and you have everything all in this big function, you have some other subtract here, it'll just blow through here, but this isn't here, right, and go all the way down. That's the same case when looking at switch statements. So that's something to think about as if you go when you do 2312. Okay. So here are the format specifiers that C uses. So for scanf, printf, scanf is just get input from the user. It's the most simple way. There are many different ways to do a lot of things, like printf. You can do it in several different ways. Scanf, you can do multiple different. There's also getLine, but I'm showing you the most simple way to do it. Okay, and then so you don't have to memorize these. Just make sure you have them offhand somewhere. The best way to code is kind of just have documentation open it to the side, and then as you code and you get to that point, you just double check the reference. If you become really good, that's what senior developers are. They just know it by heart since they've done it so much. But we don't expect you guys to do that. Then you have loops, right? If you're making a loop, you should make sure that the statements that you have do close the loop. If they do not close the loop, then you're just stuck in a loop essentially, right? So for loops, you have your first like initialization points. You can initialize variables in all of these. It's just that generally this is where you initialize, or you can actually use a different value, or not include it at all if you want. What some people will do instead of while, they'll just delete everything that's inside the for loop at the top, right? So it'll run forever. And then just include some kind of exit state for it, right? And then this is the conditional statement to continue, right? It'll check this. Hey, should I do another loop? And then I++. You could put I++. There's some, if you do 3318, you might do a different iterations through numbers, right? When you're trying to do the most, let's say you're searching through binary string, right? You can kind of start I think the most simple example is to go in half, right? So instead of that, you can do I divide equals, and then 2, right? So we'll divide by 2 each time, right? To kind of do some kind of operation tricks instead of doing every single option. Then you have while loops. These statements don't start unless the first condition is true first. That is compared to do while loops is they will run, right? But they'll double check for while. Good implementation for do while is when you're getting input from a user. Let's say you want a number, but they're giving you a character. You'll have a check. You'll get the input, have a check. Then it'll spit out a flag that, hey, they haven't entered the right process or haven't entered the right input. Then it'll just push them back up to enter it properly. That makes sense. Okay, pointers. So pointers are the hardest thing in C, probably hands down, right? Besides some of the other lower level input-output processes, okay? Pointers are just a data type to store an address, right? You reference, you have these operators, the ampersand and the, I can never remember what it was called, but asterisk, yes. Asterisk, so reference and dereference. This is just saying, hey, address of, and this is value pointed by, right? So it's kind of how you deal with data. So let's say you have and is the reference, address of, and you're trying to make a pointer to something. First, you have to set the pointer to equal to wherever the address of what you want it to point at to. That's what you're using this for. And then afterwards, once you have the pointer, you can dereference the pointer to get the value that's stored at that address, right? So you have, consider it like one block, the address that is linked to the data. And then in this sense, you have a number, right? And then you're passing the address of this to be stored in here. And this is to indicate that what this is a pointer, right? You have to declare every pointer has to be the same type that you're pointing to. Otherwise, it'll run into issues. If I make this as even though I'm only storing an address, they need to save have the same typing, right? So if I put char here instead, this wouldn't work. Any questions? Questions about pointers you want to cover? I know this is the most complex, one of the most complex things. Let's see. Okay. Creating functions. So to create functions, you have to realize that C likes to pass by value by default, right? Certain things will be passed by reference. Why are they passed by reference? This goes back to this original data type, right? So if you see these, all of these are all a type of memory address, right? The beginning of an array of something is always an address. Functions are considered an address as well. Pointers, they're addresses. They're just store addresses. So you kind of have to think about it in this way. So when you're passing stuff into functions, by default it's by value, unless the data type you're dealing with is already a type of address, right? So if you do want to pass something that isn't an address by default, so if you're passing the integer, you need to pass a pointer to that integer, right? Since you're trying to access something that is outside of the function's range. You need to have function, so you also want to have function definitions. C is also structured in kind of the same way that assembly languages is. It's top to bottom. So you need a definition first before you have a function. And you need to the program needs to know about a function before you can use it. So if you put your main function and then you put the function you're trying to use at the bottom, it doesn't know it exists, essentially. It's way too far down, right? You want to have the definitions first so that it knows it exists, then it'll run it, right? That's also, definitions get you around that ish. And then you should also have a header file just for consistency, and also when you get into those large projects, having header file is very important for statically linking stuff together in that large scale. It becomes you start to think of it as its own library almost. It needs to be statically linked together. You can also store the functions in another file, which will probably be happening for some of the C stuff. And then you use hashtag include the name of the file in the original file so that you can access that. Okay, memory management is tough, but it's really important. And it's important not to have any leaks, just to keep your program secure, especially when we're dealing with signatures, encryptions. One of the, I think it was back when ransomware was really kind of popping off, hitting a lot of people, was that if the ransomware had a leak, you can kind of use that leak to figure out what the private key that they used to encrypt all the files on your system was. So, I mean, it's good for us, bad for them, but kind of think about it in the other way, where we leak some of our information out, so our private key gets leaked in this case.
So they play themselves.
Yeah, they play themselves. But you also have to realize these memory links are not very reliable. They are a leak, right? So think of them kind of like a faucet. Once the program stops and it's done, the leak stops leaking, right? And what happens with the water after a while? It evaporates, right? That memory exists in the operating system, right? Let's say it's a chunk, right? And it's somehow gotten out of the program and it's not been kind of readjusted because you haven't freed it properly, and now the value is still stored in there. There's no guarantee you'll be able to get it, right? Because that file could be overwritten because it's free. But it could be like gone once afterwards, but it could stay for a longer time. It just depends on the computer, how the stack wants to interact with the data, and what you do on the computer, essentially. So think of it more of a leak, that it is bad, and since we don't do anything that's kind of like at the moment we only have one instance, it'll be leaking all the time. So something to think about. So there are 4 commands you really need to think about: malloc, calloc, realloc, and free, right? The main difference between malloc and calloc is one will zero out the values that you get, and the other will not. One thing that a lot of people don't think about is that it takes work to zero out values for a computer, right? That's extra stuff it has to put in. So in some cases, you don't care. It's fine if there is some data that is old in there that no one really cares about, or like kind of artifacts-ish. But sometimes it is really important. You want a fresh set of memory, all zeroed for you. And reallocate is just to, let's say if you've calloc or malloc a certain amount of memory, and you want to expand that memory, right? Realloc will let you reallocate that memory in a sense, right? Kind of what they sound like. And then free is just anything you need to, anything you dynamically make and you're pointing to with a pointer, you need to free it. But you also do not want to call free more than once. If it's already free, you don't want to call it again, because then you're freeing something that doesn't exist. Segmentation faults, kind of the hallmark of C. You see people going around wearing segmentation fault. They were kind of referencing C and dealing with some of the memory management. In large projects, it's hard to make sure everything is properly managed. Memory, any point where, let's say, your test, whatever you test, is within a certain range, and then if you go outside that range, now you're going further than whatever you've allocated in memory, right? There are no breaks on C. So everything that you're doing, you need to know what you're doing. Otherwise, compared to other languages where, let's say if you have a for loop, it'll go until the end of the array and then it'll stop for you. We don't have those. Yeah, and then again, especially interested pointers, because segmentation faults don't tell you where they are, right? You can kind of figure out where they are using printf statements. If you paste one in, you can figure out what part of the code is causing those, but you also need to reevaluate everything that you do in some cases. Where is the range off by 1? Because unlike normal counting, right, programmers count from 0. So everything starts from 0. If you don't have your range set properly, you're going outside of an array. And then it's like, okay, what just happened? You're accessing the memory you don't have, in a sense. Files. Files are very important to having persistence in any kind of program. So to set up a file, first you have to create a stream. In C++, this is very easy to do and less complex because it does a lot of the formatting for you if you do take from it. So if you go back, I'll show you what that looks like. Here, if you see C out, where's my pointer? Okay. C out global end, right? C out is just send to console. It's basically the same as printf, and then you're passing something in, and then this is an end of line message. So saying, hey, put global out on the console, and then end the line, so go to a new line. That's kind of the really easy way. That's one of the things I do like about C++. Less management. And then fopen, open a file, right? fprintf, so you're right, if you're put, instead of sending whatever you want to print to the console, which is std out, right? You're sending it to whatever file you're specifying. fscanf, which is to read from that stream, right? And you have to think of whenever you're reading as kind of you have a pointer to an address, and you're continuously moving that pointer, right? Again, going back to this low-level code example where you're, if you go through, you say get a line. Now your pointer is looking at the second line, right? Your stream is looking at the second line. And you can kind of think of it as an address as well. So it's pushing, going through each address. So if you want to go back to the beginning, right, easy way to do that is just to have fseek and then 0, 0. So go back to the beginning where it started. Okay. Now is we have 7. We do have 20 plus 50 minutes if you wanted to work on it now. This is your final takeaway for this. You can do either of the 3 things listed above. Create a banking system. If you want to be specific about that, anything an ATM should be able to do, you should be able to do in your program, right? So withdraw, deposit, check account balance, basic things. Or you could create a quest line based text game, right? Or if you have your own idea, you can do that as well. And we would like to have this by the 20th before we start the project, so we can see kind of your code, how your code is, and kind of do a little bit of code review, and kind of tackle that. Are there any questions? But also, let me hand out the sign sheet. Other than that, that's a presentation. Unless you guys have any questions.
We were talking about knock and talk, how one of those zero calendar. Which one?
I can never remember, but I can check it for you right now. A good resource to use is generally Geeks for Geeks. They have some of the best examples I've seen on the internet. So for Calc is the one that zeroes everything out.
I have a question.
Yes.
How do you go about troubleshooting C stuff?
Printf is one of the easiest ways, right? So kind of check your values. It's kind of the same thing as using a normal debugger, but more manual, right? Yes. So GDB is the university's way of tackling that kind of problem. The way, if you see yourself working a lot in C or C++ further down the line, this project we probably want to focus on just using Visual Studio Code, just because that is the most future-proof kind of IDE at the moment that we see staying for a long time. It would be Visual Studio, standard Visual Studio, right? Because it's a full IDE, it gives you some of the extra things you don't normally expect, right? Even with GDB, it might not tell you, might not give you the most friendly approach of tackling it. It's okay if I unplug your phone?
Oh yeah, thanks for the review. Also, but I have my phone over there. Oh, let's see. Thank you so much. We're all set. I would have forgotten again.
I think I have a project pre-made.
To demonstrate some C troubleshooting?
Yes.
Ooh.
So some of the advantages of using Visual Studio.
The Raspberry stuff was like supposed to like fill out the other half, the other hour initially, right?
Yes.
Oh, okay.
So say I open this. I'm not sure if it'll work
Mhm.
the way I'd like it to. Can add a bunch of. So this is a full-fledged ID, so you get some of the extra features. So breakpoints are kind of easy to place.
Oh yeah. Isn't this also in something else?
Say again?
That feature is also in something else.
GDB also has it. Yeah, VS Code also has it, but they don't have. They have it here.
Yeah.
So they do have it, but it's not as advanced as with the ID. So if this will run, I'm not sure if it will run. Right? You get some of these extra features on the side. So it'll give you processor memory, CPU percentage, some event stuff. Let me see. Ready. I think it doesn't like it. This is actually a Linux project, not a Windows project, which might be the reason, and I don't have it fully set up. But you can see here, if you had variables, right, and you had a breakpoint, you can actually see the variable name here, and it'll tell you the exact value that's being stored in that variable. And it's kind of really nice, easy UI way of looking at the variables instead of printfing every second. You can just put a bunch of breakpoints and then iterate through it. And I guess that's all if you guys want to go.
Thank you.
Mhm.
I have a question. So, I already made a bank system application in C++. So
Mhm.
those accounts.
This has to be in C.
It has to be in C?
Yes.
Oh, okay.
So you can kind of refactor it if you would like to work in C because they're pretty similar. You're just removing. They use much encapsulation. Encapsulation as in the classes.
Oh, no, I didn't use class.
So it might be 90% just before that,
Okay.
and then the last 10% might be a little bit. C is just adding those classes on top. A lot of people will use C with classes, right? And classes they can add a little bit of overhead, ish, depending on how they implement them. One of the hot takes in programming is that object-oriented programming is garbage, right? But it is a hot take, and for certain cases, I think it was kind of the. So for JavaScript, it makes a lot of sense, right? You have a lot of objects in the browser. You have kind of like windows and such. You treat those each as objects, and that is very efficient for making web pages, apps, and such. And that might not be the best way. That's what people say. Might not be the best way to for other problems, which you don't need to treat everything as an object. Also, inheritance becomes a kind of an issue if you do that a lot. So, I don't know if you cover inheritance.
Not yet.
Okay,
I will take my 1325 next semester. So.
Okay. So object inheritance is basically you have a class, right, and then you can pass certain variables or like functions to another class. So it inherits.
Oh,
from the
yeah,
class
yeah,
above,
yeah.
right? So that is another issue that a lot of people point at to cause
Really?
problems.
Why?
Because it's extra bloat. Why do you need to inherit? Doesn't make any fun. You know, testing and doing all the other features. It's seen as being adding extra bloat. You're making, they call it being object oriented just cause. Right?
Just
You know, it's not the best way of approaching it. You're adding more complexity to something that could be done a lot simpler with just procedurally running through it.
Alright. Alright. Did you want to see my bank cache or something?
I mean, sure, if you want to.
So basically, I just make it to make a user. You can log in, sign up, and exit. So let's say you want to sign up, you can use enter a user, in a password, use like 12, and then you get like silver credit. Then you can log in, like, user. Then you can just like withdraw deposit and check balance. So it's kind of basic, but it's like this you want to looking for the
Yes, that is.
something like that.
You just do that all in C, then you should be good. Can I see it, Tony?
Yeah, for sure.
Just the one.
Yeah, sure. So yeah, I just use different files that you want to.
Switch the plans. Yeah, so this file input output is probably going to be the hardest part to translate over to C.
Really?
Because of how manual it is. But since you're making it all from scratch, you can probably do it.
Yeah.
Compared to taking something that isn't as formatted is pretty. Alright, looks
Right. Yeah, I will do this from scratch.
and then put it on Git. Was Char able to reach out to you with the Git stuff?
No.
Okay. Basically, all you need to do is install Git. I think
I already
one
have
of
it.
you already have it.
Yeah.
Have you used it before?
Yeah, I upload this system on my repository on Git.
Okay. So I guess whenever you're done with the Simon ish, you can just upload it to Git, and then you can just post it in Project Share.
Ah, okay. You see. Okay.
Okay. All right, perfect.
I'm curious, where is your family from? Because you have a very interesting accent.
Really? Mexico.
Oh, really?
Mexico.
Okay, because yeah, I was somewhere talking to a buddy of mine, but if I remember right, he wasn't from Mexico. Yeah, my family is also from Mexico.
Nice.
Yeah.
For where from Mexico?